Okay, my friends, this is going to get real interesting. Everybody's talking about climate change. I got something from a good friend, and she sent me this nice movie, but it's all about climate change denial. So let's see, is there any truth that is there any climate change? How does this whole system work between us and the sun, and between us and heat? I can explain the whole thing, and I will, so get ready. All right, this is the key to the whole thing right here. Self-interest, big government funding. Listen to what he has to say.
Our careers depend on funding of climate research. This is what I've been doing just about my whole career. This is what the other climate researchers are doing with their whole career. They don't want this to end.
If CO2 isn't having the huge negative impacts that we claimed it was having originally, how are we going to stay in business?
This is the key. It is CO2, but it's the expansion. It's not just because it's carbon. All right, I want you to listen to this very carefully because scientists are all under the same thumb. Listen.
We claimed it was having originally, how are we going to stay in business?
A lot of people's livelihoods depend on it. They're not going to give that up.
This is a story of the corruption of science.
Yes, the corruption of science right across the board. This is just the tip of the iceberg.
There's no such thing as a climate emergency happening on this planet now.
He's wrong. There's 100% climate emergency. There's nothing you can do about it because it's the expansion of the gases.
There's no evidence of one.
That's ridiculous. Absolutely ridiculous.
The climate alarm is nonsense, you know, it's a hoax. I've never liked hoax. I think scam is a better word, but
all of science now is a scam. I have come forth with all kinds of things that not a single one will talk about. Now, I'd like to see these guys talk to me. And Kenitha, who says, you got to see this, you're going to see it, and you're going to believe this. I said, no, I'm not going to believe it at all because it's not true. And I did look into this, Kenitha. I told her, I said, I don't remember looking into it, but I did. I looked in, I was up to like 25 minutes or 27 minutes or something, and I finally said, these guys are just off the wall crazy, wrong. And I'll tell you exactly why they're wrong, and I'll show you why they're wrong. But this is the kind of stuff that is wrong. And everything else about fossils and about our history and about everything is wrong in science. And it's just like you said, it's a business now. You go against the tide and you drowned. So just to let him finish off, he says it's a scam. And it is. The whole thing is a scam.
I'm willing to live with hoax.
It's a story about the bullying and intimidation of anyone who dares to challenge the climate.
Dares to challenge any of the scientists, any of the experts. They will destroy you and ruin your life, just like they did to Velikovsky, just like they're doing to me.
Alarm. To speak up against or about climate change in any sort of skeptical way was essentially career suicide.
It's career suicide in any of the sciences. You say, let's look into the giants and the mud fossils that Roger Spur, Mudfossil University on YouTube, discovered 15 years ago, did DNA tests, CAT scans, everything else, washed from history because of scam. And it's the top universities that are the biggest scammers of all. Okay, my friends, Roger once again, Mudfossil University. Let's talk about the climate. There's a big discussion. Is there really a climate issue or is there not a climate issue? What evidence can we present? This is a pretty good little presentation here, but it's not right. You know, they're talking about, it's all about money, yes. Once they start funding something, they just want it to continue, keep rolling down the road. They don't care what happens as long as they're getting self-interested money, grants, and funding. And they present this very well. And they show the rocket ship rise of increase in money because we do have a climate issue. Everybody says, oh, we don't have a climate issue. No, we do have a climate issue. And I'm going to show you what it's related to. And they have no idea what it's even related to. They don't even understand that the universe is saturated with particles that we scrub through. And yes, it is a globe, and yes, it spins, and yes, it circles the sun. And yes, there is space, and yes, it is dense with particles. Okay, I am a material sort of researcher. I do material research. These are the particles that they have found at Fermilab and CERN, the black one and the red one. And the red one has no mass to it, but all kinds of energy. And this one has all the mass. And basically that's what they say. Now, there is something here that's called the quantum foam. All right, which is these particles in space as they're traveling, because this is light. And the quantum foam is this. It says modern physics deals with some ridiculous non-intuitive stuff. Yes. Empty space isn't empty. They know this. This goes back 10 years. I'm over that. Empty space isn't empty. It's filled with particles. And this is exactly what he says. The foam on the head of a root beer is complicated environment, bubbling bubbles appearing and disappearing, and a dizzying display of change. Empty space experiences similar activity. So it's empty. There's nothing there. Well, how come it's going blah, 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 blah? That's because light is coming through and hitting all the particles of other light and dust and everything else that's out there, and they're lighting up. It was seen by John Glenn. He called them fireflies. This is the first time any American went into space, and he said, I'm seeing these fireflies. And he would see them as he was coming around the edge of the earth and leaving the light and looking back through the light like dust in a barn. You see all these particles lit up. That's what he was seeing. And they just dismissed it. Oh, forget about it. But it's a dizzying display of change. Empty space experiences the similar activity. Subatomic. That means smaller than atoms. So that's light. Subatomic particles winking light in and out of existence while they hit other particles. These subatomic particles are real and have a measurable impact on our universe. Exactly correct. Why isn't this taken into account? I'll show you the impact it has, and it accounts for every single thing that we have, and global warming. All right, let's start from the beginning. The sun emits radiation. Nobody can deny that. It hits our Earth and heats up the atmosphere and lights up the skies. Nobody can deny that. Now, what is missing here is all the particles that are emitted from the sun. They radiate in real fast little spinners and little slow spinners, but they all hit our atmosphere out here, but only on the side facing the sun. Back here, you got your moon maybe illuminated a little bit, but just in a basic, real low range, not enough to create any heat. This is where you have all your heat. And what is heat? What is heat? It's a flow of particles. That's what it is. These are particles flowing out from the sun into our atmosphere. That's what heat is. It's an inflow of particles. All right, now this is the key to the whole situation here. The sun is moving this way on the arm of the Milky Way. I will show you in a minute. And we are all spiraling around the sun. And at the same time, the sun is irradiating the surface that is facing the sun and heating that surface up. The outside surface is cold in relation to the inside surface, which is energetic because of the sun and what they call a solar wind. It's nothing more than light and actually debris coming off the sun, because not just light comes off of here. All kinds of stuff come off of there. Big chunks, little chunks, and so forth. Not huge stuff, I don't think. It's got to be a certain size to be able to escape, I believe, but that's not for certain, because you see huge things flowing out of the sun, and they come back to the sun because it'll attract the biggest things. But the lightest ones that have the energy, they take right off, and I will show you that right now. But don't forget, we have to plow through all that stuff. Okay, this is, let's call this the Milky Way. Now, it's a galaxy, and we are in a galaxy. And what does a galaxy do? It spins. And why does it spin? It's moving through space just as everything else is, and it is condensing the matter into what they call a black hole, which pretty much is correct. There's going to be a black core with all of this white stuff attracted to it and being forced into it. And the Russians did this in space, created a black hole. I'll show you that in a minute. But as we're coming through space on one of the arms of the Milky Way, we have to plow through whatever's in front of us. This whole thing is rotating this way. There's just not nothing there. There's something there we have to get through. And it could be hitting us strongly or not strong at all. You could be in a blank spot and just walking through it. Or you could be crossing an arm like this and you really get reaction because you got to plow through it. Simple as that. You see that? That's the Russians did this in space. They didn't know what they did. During the experiment, we contacted the Earth guys who couldn't believe it either, and then they just let it fall off the page. They created a black hole. That's dark matter. That's dark matter. It's the separated black particles, and then the white particles, which are the charged particles, are attracted to it, forcing it to congeal in the center. Because the black particles, they don't push anybody away. The white ones, they want their own zones. So the only reason these are snugged up together is because they're so desperately attached to the black. And they get more and more dense attached to it as they congeal. Originally it was going boing, 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 boing. And it will do that until it really creates a very unique layer around here. And they couldn't believe, this goes back 10 years ago. This is 10 years ago. And I tried to get in touch with the Russians and Fermilab and everything. It didn't work out well. They also found DNA just spontaneously came together in space when they did this in this vacuum chamber with charged particles. The charges, well, you can see what you see. Make of it what you will. All right, this makes the particles pretty obvious. You see that red spot, that red spot, that red spot. And over here, there's no red spots. This is a solar eclipse. So this is the moon on top of the solar disk, and that's the only way. Otherwise you can't look into the light and see anything. You have to have the covering of the disk, and that's what happens in a solar eclipse. And this is just a perfect example. Now, what is all this stuff? What's going on here? Why are these big red jobbers going here? And why is this sort of straight up and down here? Well, this is the pole. All right, let's say that's the north and that's the south pole. So the sun itself is spinning on its axis this way because it has poles. When something spins on an axis, it creates poles. And it appears that these are the interaction zones that give it the pulses that emit these energy fluctuations. You see that? One right in the middle and one on each one of these edges here. So you got 1, 2, 3, 4, 5, 6, 7, 8, which surround the sun. These you don't see because they're sloughing off, but all the particles are coming off of here. These are the impact zones. All right, all of that stuff is flowing away from the sun, and that's what impacts our planet. And everywhere else, it just goes off into space. Now, what does it consist of? Well, we know it's light. We know light is coming down. What else? Well, there's going to be some molecules that are not completely light. They're going to be pieces of atoms. They're going to be subatomic particles. Just precisely, exactly as they said in the quantum foam. These subatomic particles are real and have a measurable impact on the universe. Yes, they do, because we have to plow through them. Don't forget, we're working in the subatomic realm in the light range, which is much smaller than atoms. These are what atoms would look like. That would be a neutron, and that would be a proton. And in my world, instead of a neutron and a proton being these big balls that can break into all that stuff, They're both made of these particles, and a neutron is only one bigger than a proton. A proton is an uneven number. It's a charged particle. It wants one more, or it wants to give one up. That's what the nature of a proton is. A neutron says, I got exactly the number I want. Don't bring any more, and I'm not giving any up. But when you hit them head on, they explode. All these particles go flying. Now, what happens to those particles? Well, some of them come out in big chunks like this, X they call them. They're just big chunks of things that damage very, very dangerous particles. And then some of them come out to be the tiniest little balls, which are the electron neutrinos, the red, blue, and the green. Some of them come out to be photons, but they're only breakdowns of these two little particles, which is the black and the white one, which is the dipole electrons. I don't want to get too deep into this because this is where I start to lose people. But these are the two particles that make up everything. Each one of these little pieces has one of these and one of these attached together, just like that. This is a bar magnet, basically. Now, two bar magnets together make a photon, that's a photon. So it's really made of two little bar magnets attached together, and they are tight as hell. They do not want to fall apart. They bounce. That's why light comes down and bounces back at you. The more light you send down, the more it bounces back. Simple as that. And the stronger the frequency, the brighter the light. And this is what we use. We started with light. They started with these huge particles and had just a big mess of things to dig through. We started with this. We can see the actual photons, and then we can actually see those photons divide, which is the cat's meow, my friend, right here. The black separated from the white. Black and white. Here it is. There's their muon, which is the black one. Never changes size. Here's the electron neutrinos, the white ones, and they turn into showers. It's exactly what it did. They come down like this, the light, and then because of the Venturi, it crushes the fields and then they expand. Here's the division and here's the come back together. That's fission and that's fusion. Now, we're talking about saving energy. There's no energy input to here at all whatsoever to create that white energy, and that white energy is electricity. And there's really no reason we can't make free energy with this. I'm almost certain. This is what you want for energy. That white is raw white energy. It's electricity. That is what you pump into your batteries in your car. It weighs nothing. When you add your electricity to your car, the car doesn't get heavier. When you use it all up, it doesn't get lighter. This stuff has virtually no weight, but it wants so desperately to come back to that black that it will push everything out of its way. But it has no weight. It has a field. And the field actually does the pushing. So if that's all we want to capture is the white, we should be able to put a collector right there and let that white hit, and the black won't be there. The black will be gone somewhere else. It's not going to get through this Venturi. And you can't see the Venturi because there's so much explosion here. But here's what it would be like. The laser would send the light through the Venturi. The black can't get through. Only the white gets through. It hits the solar collector here and right down into your batteries. Do whatever you want with it. And it's portable. You can walk around with it. It's not something, and it's going to be very light and cheap and inexpensive if it works. But if you put a collector there and you just harvested that white, no weight to that whatsoever. It doesn't weigh anything. Okay, let's get into some fun stuff. This is a Crookes radiometer. Now it has white veins and it has black veins. The black veins all face this way. The white veins face the other way. So when you shine a light onto it, you would think the white is going to bounce the light back and the white would push away from this white. That's the normal thought process. But it works just the opposite. Now watch. I'm going to focus this right in here. Now I'm going to go right against the black. Watch what happens. Boom, takes right off. You see it? Now I'm going to go against the white. And guess what? It gets even faster going towards the white. The white doesn't push it back. The white sucks it towards the white. Now, why does that happen? You wouldn't think that would happen. Now, the blue is way up here in the visible spectrum, but it's a powerful. As you saw, the red, which is down here in the visible spectrum, you can't see it. I mean, it doesn't have any power, but the blue does. Watch the blue. See, it's not as powerful as the white. White has all the power, but blue has enough power. Well, it did a second ago. You see it moving it? And against the white, it draws the white to it. You see that? It's not pushing the white away. It's drawing the white to it. Just barely. If we had real strong lasers, you'd be able to see it. But the point being is that the white opposes the black. And it pushes the black very fast. And the white pulls, it pulls the white towards it. You see that? It's pulling the white towards it. It's not pushing it back whatsoever. And that white will pull that white towards it forever. Why? Why would the white be pulled towards the white? And why would the white push the black? It does both things. It pushes the black harder than it pulls the white. But it does absolutely pull the white. Alright, this is outrageous. This is my atomic model, is dipole electron flood theory, which means all the dark particles that are normally attached to the white particles are surrounded by the white particles. All right, they go to the center. They don't push each other apart. They glob right to the center. That's where the dark matter has always been hiding, inside of the atom. That's what dark matter is. Now, watch this. I am going to shine this light on that white vein. There's white and black veins. This is a Crookes radiometer. And the black, if I shine it on the black, it spins. Now, if I shine it on the white, what would you expect to happen? It actually pulls it towards the light. Watch what happens. Nobody can explain this. 150 years, still nobody can explain this phenomena. And I can. I know exactly why it's happening. Watch what happens. The light will hit that and it'll come towards the light. You see it coming towards us? Why would it do that? There's nobody can explain that except Roger. All right, so I want you to tell me why you think that happens. Why do you think that happens? All right, the only way for you to understand what I just showed you is to understand dipole electron flood theory, which means the black and the white, they're separate. They're separate particles. They can go their own separate ways, and they do. And inside of an atom, the white surrounds the black. It depends on how big it is. The more black stuff there is, the more white stuff there is. Simple as that. And that makes bigger and bigger atoms. But these are the only two things that exist. An electron neutrino and a muon neutrino, tiniest particles. And then you had these two together make what they call a gluon, which is nothing more than what we would have called an electron. But they didn't realize the black part was attached. Now, two of these together make a photon. This is heat, electricity. It wants to incorporate into something. This wants to bounce away from something. It has a field surrounding the whole particle. This only has a field here. So it becomes attractive or repulsive, but it wants to engage. This one just wants to bounce. All right, but that's going to go in as heat or electricity, basically. Now, there's going to be changes to everything. Chemistry's got to change. The atomic model is wrong. Hydrogen is not one proton and one electron. It's 1,825 or so dipoles. Everything in space has to change. The space is saturated with particles. We think we're looking out and seeing the stars and the planets so far away. Who knows how far they are? It depends on what's in between them and us, how slow the light comes, because we think it goes the same speed of light everywhere. That's just not true. I could show that very simple, and I did. So the redshift is just totally wrong. And it's only based on Einstein's claim light travels at the same speed. This is obviously not true. No question whatsoever it's not true. That's light. And that's speeding up. And I can show it slowing down too. And now here is a separating. And this is really an atomic, subatomic nuclear explosion. This is a nuclear subatomic explosion. That particle was that little four-banger together, the two blacks and two whites. It started to speed up like crazy, and here it exploded. That's fission. Come back together, that's fusion. And I didn't make this chart right here. This is from Fermilab or CERN, but this is the muon neutrino, the black ball. And this is talking about Cherenkov radiation. And they can see this happen, but they just don't understand it. The electron neutrino separates from the muon neutrino and becomes a shower. The muon goes into a sterile mode, they call it. That's exactly it right there. There's no question whatsoever. That's it. We started with light. Light is light. And the green light is exactly the same as the red light and the blue light, only the green is the middle speed. The blue is really fast, and the red is sort of slow. But they're all the same particle. And here's the red somewhere. Here's the red one is we're using here. And there's the particle. And here's the side that can get glowy because it's going this way, interacting with these particles in front of it, charging it up. That one discharges, and sooner or later it'll flip to the front. And that's what causes them to spin. And they call it the muon wobble. These are muons. All right, listen to this now. This is the densities of the atmosphere and how they react with particles. This is way outside, almost into space, really, which has a very low density. Still plenty of particles out there. It's saturated with light. Now, you come below that and you get into the ionosphere. This is it's plus 1,500 degrees Celsius. That's like thousands of degrees. Now, it's a dipole effect, so all of your electrons are being collected out here, and the electrons are the ones that really burn things. Now, that means that all of the dipole parts, the muon electron, the muon neutrinos, will accumulate here. And this is the coolest part. They don't have any energy. They have no energy whatsoever. So it's minus 80 degrees Celsius. That's over 100 degrees below zero. And then again, you're going to have a hot layer because it's hot, and then cold, which is the Earth. The Earth will suck all those electrons down into it. But in between this really cold layer and here to Earth, this is where it's heating up. Now, what is it also doing? A lot more scrub, a lot more turmoil, a lot more turbulence, a lot more tornadoes. And a lot more heat, and a lot more condensation. And because it's so cold up here, when it condenses right on that edge, you're going to get gigantic chunks of hail come down. Huge, monstrous things. And they're coming down. They're going to get bigger and bigger. So this accounts for everything that is happening right now, because this layer here is being pushed out. And it's just getting harder and harder and harder, scrubbing harder and harder and harder out here. It's just pushing out. We're just blowing up like a balloon. It's as simple as that. All right, let me just be 100% clear on this. The entire universe is filled with particles of light and dust and all kinds of debris, making these huge cloud swirly patterns in the galaxies and so forth. And all light has to come through that is going to slow down. So we don't really know where we are in space. That's one thing. Secondly, as our planet scrubs through all of this debris out here, it gets warm, real hot out here, thousands of degrees, thousands. Now, as we expand our envelope of gases, it's going to get hotter and hotter. There's going to be much more turmoil, exactly what we're seeing. As we convert solid state matter, coal, fossil fuels into gases, the expansion is just astronomical. So if this layer was here and it gets to be out here, it's all over, and it is damn near out there. So this is what I say is causing global warming, and it's I don't see how we can reverse it. Now, the only other possibility is that we're hitting a very dense region in space. It will do the same thing as if our atmosphere got big, big, big like this. It's going to do the same thing if we hit a real dense place in space, even though it was down here. So it could be one or the other. Now, the sun has the same problem. Well, it's not a problem for the sun. It's just exactly what it wants. It plows through the universe just as we do. But when it hits, it's so big that out here it forms the corona. Millions of degrees out here, only 10,000 on the surface. That's because it's scrubbing the same way we are. Thousands of degrees out here. Thousands. Everybody thinks, oh, it's cold out there. No. At the very edge where the ionosphere is, it's thousands of degrees. And then it gets cold just below that. And then it gets hot but just below that. And then it gets cold as it enters the Earth. All electricity wants to get to ground. This sucks electrons. It wants the electrons. All the electrons coming from the sun, if they don't hit something, they go into the ground. Simple as that. The Earth is the collector of electrons, and there's zones because everything's a dipole. The first hit is where it's really, really hot, then it gets really, really cold, then it gets really hot, not real hot, but hot again, and then you get to the Earth. That's the layers of dissipation of heat, and they show it like this. All right, there's the outer space basically. Here is where you have all those ions, all those electrons gather here as they scrub. That's the scrub zone right there. And that's thousands of degrees. It's 1,500 degrees Celsius. That's thousands. Here, it gets down to minus 80 degrees Celsius. Why? Why? Because it's a dipole. A dipole means there's two pieces to it, the hot side and the cold side. This is absolute zero. There's no, you know, it's mixed in with other things, so it's not going to be down to absolute zero, but it's over 100 degrees below zero. And this is a couple thousand degrees above zero. And they're both right one little layer holding them apart. And then because this is so cold, you have the opposite again. Now the hot comes down here, and then the hot filters into ground. Ground absorbs everything, the electrons. Now, this is the part that had me confused for quite some time. I was thinking, well, we're going around the sun this way. That would push this side of the Earth and make the Earth spin that way. But the Earth is spinning this way. Why would it spin this way? Well, here's the reason. The sun is making this really reactive and expanded. So as we spin this way, this is the like almost like a wall hitting here and spinning it. Here you don't have any heat, so you don't have any big radiation, any glow. So it spins this way. As soon as it hits the heat again, it spins it like a propeller. So we're spinning this direction, and we're going to spin at almost constant speed because pretty much we're flowing through the same sort of particles. Now, here's the key though. Space is not a stagnant, just one fluid, one amount of gases and particles. No, there's all kinds of different layers of particles, and we may be entering a really dense region, which would cause all kinds of havoc in the atmosphere because we got to crush through it. And it would also heat up the sun and make coronal mass ejections, because that is got to plow through space just like we have to. But not only is the sun moving this way through space and spinning at the same time, we are moving that way through space and spinning around here and spinning on our axis at the same time. So that's the interplay of the pieces. Now, think about why this is spinning this direction as we go that way around the sun. It's counterintuitive, but it makes sense once you understand this is the impact zone. So this is where the propeller blades stick out, and it pushes it this way. Out here you don't have any propeller blades. There's nothing for it to bang into. So it spins in that direction.